Similarly, to estimate lower quartile Q1 from a cumulative frequency curve, we find the position of lower quartile by using n over 4. So in our case, n is 40, so we have 40 divided by 4 and it will be equals to 10. So now we look for the data value corresponding to the cumulative frequency of 10. So from 10, we will draw a horizontal line until it intersects the curve. Now from the point of intersection on the curve, we will draw a vertical line until it touches the x-axis. So the value is 4.4 in our case. That's why an estimate of lower quartile Q1 is equals to 4.4 hours. Now to estimate upper quartile Q3 from the cumulative frequency curve, we find the position of Q3 by using 3 over 4n, and in our case this is 3 over 4 multiplied by 40. So here we have 10, 3 multiplied by 10 is 30. Now we will look for the data value corresponding to the cumulative frequency of 30. So from 30 we will draw a horizontal line until it touches the curve. Now from the point of intersection on the curve we will draw a vertical line until it touches the x-axis. So here the value is 6.6. So from the curve, that's why an estimate of upper quartile Q3 is equals to 6.6 hours. And that's why an estimate of interquartile range is equals to Q3 minus Q1, and in our case Q3 is 6.6 and Q1 is 4.4, so it will be equals to 2.2 hours. Now, an estimate of the range is the difference between the t-coordinate of the largest endpoint and the t-coordinate of the smallest endpoint of the cumulative frequency curve. In other words, the estimate of the range is equals to 10 minus 0, and it will be equals to 10 hours. Since the smallest estimated value is 0 and the largest estimated value is 10. For the cumulative frequency curve, we can also find a measure called percentiles. Are the values that divide the dataset into 100 equal parts. For example, in the counter frequency curve that we can see, 80% of the distribution is equals to 80 divided by 100 multiplied by total number of students, and that is 40. So here we have 32 students. Now from 32 students, we'll look the data value correspond to the cumulative frequency value of 32 in the cumulative frequency curve. So from 32 we will draw a horizontal line until it cuts the curve. Now from the point of intersection on the curve we will draw a vertical line until it touches the horizontal axis, where we have the value 7. So we say that an estimate of eightieth percentile or PAT is equals to 7 hours. The median or Q2 is same as the 50th percentile. Similarly, lower quartile is same as the 25th percentile, and upper quartile or third quartile is equals to or same as the 75th percentile. Now in the exercise 3B, question 1, find the range lower quartile, median, upper quartile and interquartile range for the following set of data. In the part A, we have the data set 7, 6, 4, 8, 2, 5 and 10. So first we will arrange the data set in the ascending order. Here we have 2, 4, 6, 7, 8. Here we have 2, 4, 5, 6, 7, 8, and 10. Now the total frequency, the value of n is equals to 7. Now first we have to find out the range. So to find out the range, we will use the formula largest value minus smallest value. So the largest value in the dataset is 10, and the smallest value in dataset is 2, and that is equals to 8. So the range is equals to 8. Now to find out the median, to find out the position of the median, we will use the formula n plus 1 divided by 2, and since n is equals to 7, so 7 plus 1 is equals to divided by 2 is equals to 8 over 2, and it will equals to 4. So the median is equals to, the position of the median is equals to 4. So the median is 6. Or the second quartile Q2. We can see that this median divides the dataset into two halves, having the 3 values on each side of the median. So for the 3 values on the left side of the median, the middle value of the 5 values is 4, which is the lower quartile Q1. So the lower quartile Q1 is equals to 4. Now we consider the 3 values at the left side, at the right side of the median, and the middle value of these 3 values is 8, and this middle value is the upper quartile or the third quartile Q3. So the upper quartile Q3 is equals to 8. Now we have to find out the interquartile range by using the formula Q3 minus Q1. Since the upper quartile is 8 and the lower quartile is 4, so 8 minus 4 is equals to 4. So the interquartile range is equals to 4. And median is equals to 6. The part B, we will arrange the data values in the ascending order. So here we have 51, 54, 63, 64, 66, 70, 72, and at the end 80. Now the total frequency of the dataset is 1, 2, 3, 4, 5, 6, 7, 8. So the total frequency n is equals to 8. Now to find out the range, we will subtract the largest value from the smallest value. So the largest value here is 80 and the smallest value is 51. So 80 minus 51 29. So the range is equals to 29. Since we have discussed that when the n is even, then the median is the mean of the two middle values. So median lies here something between 64 and 66. So median is equals to 64 plus 66 divided by 2, and it will be equals to 66 plus 64 is 130 divided by 2, and it will be equals to 65. So the median is equals to 65. Now to find out the lower quartile. Now here we have the lower half, and here we have the upper half. So when the number of data in the lower half is even, then the lower quartile Q1 is the mean of the two middle values. So the two middle values in the lower half are 54 plus 63 divided by 2. So 54 and 63 goes 117 divided by 2, and it will be equals to 71. And it will be equals to 58.5. Now for upper quartile, when the number of data in the upper half is even, then the Q3 is the mean of the two middle values. So the Q3 is the mean of the two middle values. So the two middle values here are 70 plus 2, 72 divided by 2. So here we have 142 divided by 2, and it will be equals to 71. So the upper quartile is equals to 71. Now for interquartile range, we use the formula Q3 minus Q1. So Q3 is 71 and Q1 is 58.5, and it will be equals to 12.5. So interquartile range is equals to 12.5. Now for part C, we will arrange the data points in the ascending order. So here we have 9, 10, 14, 16, 18, 22, 27, 32, and 40. So now to find out the range, we will subtract the smallest value from the largest value. So the largest value is 40 and the smallest value is 9, and it will be equals to 31. So the range is equals to 31. Now to find out the lower quartile. Now first to find out the median. Since the n is odd, so the position of the median is equals to n plus 1 divided by 2. Since here n is equals to 9, so here we have 9 plus 1 divided by 2, and it will be equals to 10 divided by 2, and it will gives us 5. So the fifth value is the median, and that is 18. So median is equals to 18, and we can see that median divides the data into two equal halves, having the 4 values on each side of the median. So now in the lower half we have 4 values, and in the upper half we have also 4 values. So since we know that when the number of data in the lower half is even, so the lower quartile Q1 is the mean of the two middle values. So the two middle values here is 10 plus 14 and divided by 2. So 24 divided by 2 is equals to 12. So the lower quartile is equals to 12. Now for upper quartile, Q3. When the number of data in the upper half is even, so the Q3 is the mean of the two middle values. So the two middle values in the upper half are 27 and 32. So 27, 32 divided by 2, and it will be equals to 59 over 2. And it will give us the value 29.5. So the upper quartile is equals to 29.5. Now for the interquartile range, we have the formula Q3 minus Q1. Here Q3 is 12, and here Q3 is 29.5 and Q1 is 12, and it will be equals to 17.5. So the interquartile range is equals to 17.5. Now first we will count the total frequency. So the total frequency, and in our case 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So n is equals to 10. Since we know that if n is even, then the median is the mean of the two middle values. So here the two middle values are 10.4 and 11.8. So median somewhere lies here, and here we have the lower half, and here we have the upper half. So now the median is equals to 10.4 plus 11.8 divided by 2, and 10.4 and 11.8 will be 22.2 divided by 2, and it will be equals to 11.1. So the median is equals to 11.1. Now for the lower quartile, when the values in the lower half are even, but here we have the values odd. So since we see that the median divides the data set into two equal halves, having the 5 values on each side of the median. So in the lower half, or in the right side of the median, we have 5 values, and the middle value of these 5 values is 6.7, and this is the lower quartile. So the lower quartile Q1 is equals to 6.7. Now for the 5 values on the right side of the median, the middle value is 15.1, and this is the upper quartile Q3. So the upper quartile Q3 is equals to 15.1. Now to find out the interquartile range, we have the formula Q3 minus Q1, and since Q3 is 15.1 and Q1 is 6.7, so 15.1 minus 6.7 is equals to 8.4. So the interquartile range is equals to 8.4. Now for the part D, we arrange the data into ascending order. So here we have 2.7, 4.9, 6.7, 8.5, 10.4, 11.8, 13.1, 15.1, 16.7, and 22.4. So first we have to find out the range. So the largest value here is 22.4 and the smallest value is 2.7. So 22.4 minus 2.7 is equals to 19.7. So the range is 19.7.